This structure right here is an undercroft. Its purpose is to provide protection from outdoor elements such as sunlight, rain and wind. This structure is located at Newport School in Newport on Beaconsfield Road. The focus element of this structure are the beams, secondary and primary. The material being used for the beams in this structure is steel. The designers use steel because it has a relatively high strength to weight ratio. It's also easy to form and modify. The cross-sectional profile for this beam is a C-beam. C-sections offer high bending in load bearing and soil friction for reliable anchoring. The choice of corrosion protection for this material was galvanizing. The method used in the structure to connect the beams were bolted frame connections. The beam members here in the structure of the undercroft are experiencing two main forces. One, the beam is experiencing compression on the top half of the beam, while the lower section is in tension. The failure the members would experience is bending if the bend surpasses its allowable deflection, but the structure could have a shear break in the bolt joints. This structure I chose is an awning. The initial function of an awning is to defend or protect from overbearing sunlight. It provides shade and sometimes rain protection. Window awnings can effectively decrease the amount of sunlight that is accessing the inside. The awning is also located in Newport School, at the canteen's windows to minimise light entering. The element holding up the structure is a tie. The material that is being used is steel. Steel is renowned for its superb tensile strength. Ties are put under tension in structures, hence why steel was used for this member. This tie uses a simple solid circle profile to maximise bonds and tension. The method of corrosion protection is again the commonly used galvanizing. The method of joining that has been used to connect the members to its adjoining members is a cleat and shear bolt. It's been used for flexibility of construction and less labour intensity on the site. The type of joint also easily allows any member to be joined on any angle. The member here in the structure is a tie. Here the tie is holding tension and is under tensile forces. If the above forces were increased, the tension will increase and the member would snap. This right here is a basketball hoop and stand system for a half court located down at Newport Beach. The focus element here is the strut. Once again, the material for this strut is steel. Steel is used here just for the simplicity, costs and consistency of keeping the main frame the same material. The sectional profile used for this strut is a solid circle. It's also been galvanized with Duragal for corrosion protection. The bond used to adjoin this member with the others was a weld. Compared to bolts where the pressure is put on every bolt, welding helps even out the pressure and stress that allows the connection of steel to last for a longer time. While ties are to battle against tensile forces, the strut is complementary and resists against compression. If the forces were increased, the member will most likely experience a buckle, although the first failure for the structure would appear as a bend here, if the weight force was added to the end. This here is a street light that is located off the corner of Hollywood Road. This element's material is steel, and for this case it was used for its abundance, cheap cost and ability to be shaped. The majority of the section profile is a CHS, which is a circular hollow section. The material used for this member is galvanized steel. Due to the huge number of streetlights around, for the simplicity a bolt joint was used. One, for the simplicity to construct and build, and two, because it's a metal to wood joint. The main force acting upon the member is really its own gravity, and due to the laws of mechanical advantage, a great amount of tensile force is applied on the top bolts. And if increased forces were applied, then the cantilever will act as a lever arm against the bottom of the joint, meaning for tension of the top bolts, snapping them. Other results can also be shear break or bend.